Okay, so in R6, we're going to look at division of polynomials. There's two methods you can use for dividing polynomials. One of them is long division. The other is synthetic division. Now, long division is tedious, can be confusing. It's just, to me, a lot of trouble, a lot of steps that where if you make one silly mistake, you're done. So I like to just do synthetic division. And this is what we're going to use, synthetic division, to find factors for polynomials of degree 3 or higher. And we must use division to test for factors. So if you just think about numbers, okay, when we talk about factors, factors are numbers that can divide into another number with no remainder. So in other words, if I wanted to say 6 goes into 24 4 times, and we have a 0 remainder, so we know that 6 and 4 are factors of 24. So that's similar for polynomials. We're going to test factors, or in theory, we're going to test what we call zeros. And if they give us a remainder of 0, then they are a factor and they are a 0. So it kind of goes back to what we did in 5.1, where we had polynomials in factored form and we graphed them. We're going to be taking the polynomial in expanded form and finding factors, okay? So the way we do it is synthetic division. Now, for this method, we only use numbers. And if we're given the divisor, okay, in the factored form, we make sure to use the opposite sign of R as our divisor. Just like the 0 is the opposite sign of the factor, that's what we're actually testing. We're testing the 0 itself. I see students mess this up all the time. They use the wrong sign, then everything's wrong from there on out. So you've got to make sure you understand that you're actually using what would be the 0 as a test factor. We also only use the coefficients of the terms. So if I want to just divide 6x squared minus 26x plus 12 by x minus 4, we're dividing by x minus 4, so we use positive 4 as our divisor. Now, the main setup for the synthetic division looks like this. So we put our divisor, goes here, and then our coefficients go here. So these are the coefficients. And then what I kind of do is I set up little boxes. Kind of like that. I shade in the first box. All right. So step 1 is you bring down the first coefficient to the bottom row. Sorry about that, a little sloppy there. It's a Monday. So that's that. Step 2, multiply the divisor by the number in the bottom row. So I take 6 times 4, and I get 24. So you multiply in the bottom row, and you place that number in the box below the next coefficient. Then you go ahead and combine like terms in the second column. Watch your signs, okay? You got to watch your signs. Negative 26 and 24 is negative 2. And then you repeat process until you reach last coefficient, which in this case we only have to do one more time. So the process is I multiply the divisor by this number, so 4. So I'm taking that one times 4 again, and I get negative 8. 12 and negative 8 is positive 4. So what do we know here? Well, one thing I know is that the last number, this is my remainder, is 4. My quotient, which remember your quotient is what you get after you divide. Like in other words, whatever, when we divided up here, this was my divisor, 4 was my quotient. So similarly here, say that again. My quotient comes from here. Well, my quotient is 6x minus 2. Now, how did I get that? Well, this is my remainder. So therefore, this is the term with no x, which is my constant term. I work kind of backwards. This is my coefficient of x. So you've got a constant term, coefficient of x, and depending on how many of these you have, you keep on working back. The other way to look at it is, since we started with 6x squared and we're dividing by x minus 4, we have to have something times x to get us with 6x squared. So there's several different ways to look at that. But just remember, the last number is your remainder. This is your constant term. This is your coefficient of x, so on and so forth. So let's look at another example. So let's divide 2x cubed plus 7x squared plus 5 by x plus 3 using synthetic division. So again, if we are dividing by x plus 3, this time we use negative 3 as our divisor. Set it up. Now, you notice my list of coefficients is 2, 7, 0, and 5. Some people throw 1s in there. I never say throw 1s in there. Why am I using a 0? Because I do not have an x term up here. I have x cubed, x squared, and a constant term. So since I am missing an x, we have to account for it. So I do 2, 7, 0, and 5. And I just go ahead and set up my boxes. Shade in that first box and bring down the 2 directly into the quotient row. Then I take negative 3 times 2 and put it up in here. So this is times negative 3, which gives me negative 6. Combine like terms, 7 minus 6 is 1. Repeat the process. Multiply that by negative 3 to get negative 3. 0 and negative 3 is negative 3. Again, multiply Negative 3 times negative 3 is 9. 5 plus 9 is 14. So remember, this is your remainder. Constant term, coefficient of x squared. So for this one here, my remainder is 14. My quotient is 2x squared plus x minus 3. So remember, remainder, constant term, coefficient of x squared. All right, let's just zip on through and do another example. So now we're going to use synthetic division to show that x plus 3 is a factor of this. So the last two examples we've done, they're not factors because we're getting a remainder. So just keep in mind as a side note, x plus 3 is a factor if there is no remainder. So my divisor is negative 3. Don't forget that. Or our 0, as we want to say. I've got my coefficients are 2, 5, negative 2, positive 2, negative 2, and 3. I'm not missing any powers of x, so I don't need any zeros. So get your little grid set up here. Bring down that first number into your quotient row, and then proceed to multiply. Negative 3 times 2, negative 6. Combine like terms, watch your sign. Negative 3 times negative 1, positive 3. Combine like terms, 3 minus 2, again, is positive 1. Negative 3 times 1 is negative 3. This time we've got negative 3 and positive 2, which is negative 1. Negative 3 times negative 1 is positive 3. 3 minus 2 is 1. Negative 3 times 1 is negative 3. And I have 0 as a remainder. So therefore, x plus 3 is a factor of this. So my remainder is 0, and now I got to figure out my quotient. So again, I'm going to show you both ways here. Here, that's your remainder. Don't forget that. Constant term, coefficient of x squared, coefficient of x cubed, coefficient of x to the 4th. The other way to look at this is I started with x to the 5th. So therefore, that first number has to be coefficient of x to the 4th. So my quotient is 2x to the 4th minus 1x cubed plus 1x squared minus x plus 1. All right. Last example, we want to use synthetic division to determine if x minus 2 is a factor. So up here we were showing that it was a factor. We're going to do the same thing here, but we just don't know. But again, in order to determine if x minus 2 is a factor, your remainder must be 0. So my divisor is 2. Always do the opposite sign. And in this list, I am missing an x squared. So I put down the 3, negative 6, 0x squared, minus 5, and then 10. Create my boxes. Mark through that first box. So again, x to the fourth, x cubed, x squared, x, and constant term. Bring down the 3. 2 times 3 is 6. 6 minus 6 is 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. 0 minus 5 is negative 5. 2 times negative 5 is negative 10. And I get 0. So, x minus 2 is a factor. My remainder is 0. My quotient, well, remember, that's my constant term. I don't have any x's. I don't have any x squareds. So I have 3x cubed minus 5. All right, so that's your synthetic division. We'll do more practice. This is something that you just got to practice it. Just like everything else, you just got to practice it. You just got to remember your details and follow your steps. I gave you written instructions over here on the first page. So learn those. All right, so we'll see you in class.